Hey guys, this is Hyunwoo Lee. Today I'm going to show you what is cometbft Analyzer and how it is working with real demo. Um, First, cometbft Analyzer is a open source tool for analyzing live networks or testnet networks, which is running with cometbft and Cosmos SDK tech stacks. You guys can check every details in this BFT Labs repositories, and we're gonna check demo how it is working. And yeah, you guys can grasp how it is works and why it is good. So um, this is the project dashboard. When you can see when you're logged in is cometbft Analyzer dashboard, and you can create project. So in this demo, we're gonna try to grasp how we can optimize our network latencies with this cometbft Analyzer. So let's create project. And yeah, we successfully created project. And let's assume we already running some test networks several times, and we have a bunch of commit50 logs. This is basically debug logs, which contains very details of the network. So after running test networks, you can attach these networks into create simulation. So let's create simulation first. I just created automatically generated description and name because it is not important for naming right now. And yeah, let's attach some testnet logs, and let's create a simulation. Um, yeah. Why it is processing. Let me explain brief overview for this logs. I basically ran 4 cometbft binaries in my local MacBook, and these logs are generated in my local environment. So let's see what we can do with this cometbft Analyzer. There are two dashboards right now. First one is consensus trace dashboard, and the second one is network latency dashboard. Let's go first, tracer. With consensus tracer, you can check very details of networks, what exactly happened um, during for this block number 1 and block number 2, something like that. So as you can see, there are a bunch of filters in the right panel, and yeah, for example, this mean a proposed step. This is blue color, right? Um, this is proposed step, and you can see this circle shape is different than others. That means this node is proposal. So because this node is proposal, it started to broadcast its block part. You know, this yellow line means broadcasting block part. So this node is proposal. So this node created proposal and sending block part to other nodes. So after other nodes received proposal, they started to entering pre-boot step. You can check, yeah. And after entering pre-boot step, each node will start sending pre-boot messages. You can see. So after sending pre-boot messages like this, broadcasting, and they are starting to entering pre-commit step. So every node entered pre-commit step, and they are starting to broadcast these pre-commit messages. And after sending pre-commit messages, and they started to entering commit step. And after that, it started to timeout for handling next block number like this. Yeah, so you guys can check every details of the network and with this tracer. And yeah, you can check also event logs detailed, ordered by time, ascending order. So yeah, you can check every details of this log. Yeah, this is basically what tracer does. Engineers and researchers are can take a look very details for cometbft networks. And this is the network analysis dashboard. Yeah, you guys can check every details like what kind of messages have large latency, and what is the message volume. Yeah, as you know, hash mode messages are the major in the networks. And yeah, I ran 4 nodes in my local, so every latencies, average latencies are the same basically. And also message volume, yeah. And this performance metrics table, you can check very details message count for each node pair, and latency also. Yeah, and you also can check pair details in this detail analysis dashboard, message count, and yeah, how was the distribution of latencies in detail. Yeah, this is not bad because red color and this orange color has small portion of the entire message, so it is fine. And you guys can check latency map, so you can know who was the bad performance in this test network. Because I configured same configurations for all nodes, so there are no differences. Yeah, so this is a network analysis dashboard. And let's see other case. I mean, let me show you some interesting cases. This case is the case where I configured node 0 with some large latency configurations, which is wrong because it is bad and it is different with other nodes. So node 0 has some weird configuration in this setup. So let's see what we can know with the network analyzer. Can we capture that situation or not? So this completed simulation is normal case, and this one is weird case. So let me show you. This one, the left case is a normal case, and the right case is bad case, right? So yeah, we can notice only with the summary dashboard. Latency values 113 milliseconds for average, but this one only 26 millisecond latencies. And yeah, this node is a bad performance. Started with A0. And we can check with this graph. You guys can notice other nodes has only latencies like under 80 milliseconds, but this node has 200 milliseconds because I configured for this node with high values of P2P configurations. So we can notice, during the testnet, this node has bad configurations, or there could be other reasons, but yeah. The important thing is like we can notice, yeah, every latency statistics related with this A0 node, they have high values, and yeah, also this is we can check in this latency estimate dashboard. Every node interacted with this A0 have bad performance other than nodes. Yeah, so with this network analysis dashboard, we can run several simulations and we can know what configurations would be best for our current network and what node has bad configurations or bad geolocation, something like that. All of the information in this cometbft analyzer are not possible in the default Prometheus and Grafana, cometbft Grafana. Uh, Actually, that is the point why I started to create this tool because different metrics cannot give us information like this, and I think this information is critical for developing, optimizing, and researching community in details. Yeah, so I created this tool. Yeah, and the next feature I'd like to show you guys is simulation refilling feature. With this dashboard, you guys can check every details of the network from the block height zero. So I will replay this network simulation with with 5 tick um per iteration, and I like to play autoplay to show you how this is working. Yeah, so every node right now in the pre-port step for block height 1, and they receive 2 pre-boards basically. And yeah, they are already entering pre-commit step, and some nodes already entered height 2. Yeah, they both are proposed step right now. Oh, this node is fast because it is entering pre-board step early. Yeah, for each node dashboard, you guys can check every message is received or every message is sent, and both messages so for current height. So this will be very um handy when you guys analyze your networks. And debugging also made also becomes easy with this tool. So yeah, I'd like to created this tool. You guys can think this tool as like debugger for cometbft networks or Datadog for cometbft networks because we are planning to propose other features also like abnormality detections, automatically abnormality detections. Um, that means right now it just has a tracer, but you might want to know. So what block number or what scope should I focus on? Um, for that, we are creating anomaly detection right now. So that feature basically can give you some scopes or some block numbers you should focus on, and yeah, you can just focus on that block numbers, not this entire block numbers basically. Yeah, so thank you for watching this demo. And I hope and I hope you see you guys in other places or so. Thank you for watching.